These beams of concentrated light can travel hundreds of thousands of miles without losing any focus, and Mirabeau believes that they could drive a ship into outer space.
We're now preparing for an actual free-flight experimental launch of a laser-boosted Lightcraft. We've set the model here on a short wire launcher, and we have to spin the model like a child's top or gyroscope so that it will automatically point at the laser beam during boost. So now we'll spin this up right before launch.
Laser on, air explodes, and the model rises to the stars, or in this case, the ceiling. The landing is tricky too. After all, this model is worth about $4,000 and is easily damaged. And with his models, Mirabeau is gradually increasing both the scale and the detail. Within 5 years, he hopes to lift mini satellites to orbit with a craft such as this.
This is a full-scale model of a laser-propelled Lightcraft. The entire vehicle is as you see it here. There are no external tanks. There's a small propellant tank inside. The front end of this is where the satellite electronics go. The whole front end of this thing becomes an inlet to make this engine supplied with air on the way to orbit. The back side of this is a large parabolic mirror, highly polished, that is designed to capture the laser beam that is projected to it from the ground onto this optic, and it focuses the laser power right inside this shroud here. When that happens, an explosion occurs as the air is rapidly heated, creating a shock wave that pushes this vehicle forward. As the beam is rapidly pulsed, the engine is continuously propelled on its way to orbit. Why should astronauts have all the fun? I want to go to space. I can't afford it. It's too expensive. I could afford it if it was for the price of an airline ticket. And that's why I'm developing Lightcraft technology, because it would open up space to everyone.
There's even a second generation of ideas about beam-powered spacecraft. Close to the Earth, the craft converts sunlight into electron beams that spin like a fan, moving it in any direction. Then it flips over. An orbiting solar power station hits it with a laser or microwave blast to generate 9 billion watts of electricity. This powers a remarkable engine that forces air downwards and even pushes the atmosphere out of its path. The 60-foot craft and a dozen passengers could reach the moon in just 5.5 hours. A solar-powered, virtually free ride. Outer space, by its nature, offers other opportunities for free rides.
Houston, we have satellite motion.
All right, we see it.
In orbit, for instance, a simple piece of string gains all sorts of potential. This experiment aboard the shuttle, where a satellite is being dropped into orbit, could be a step towards launching systems that work like slingshots. This attic in San Diego, California, with its futuristic spinning wheel, belongs to Joe Carroll, a man with plans for tethers in space. One of the critical jobs in the tether business is winding the reel. The string, made of high-strength polyethylene, is miles long and must deploy freely.
This is a prototype test winding with a new type of tether that is strong enough to actually tie the space shuttle to the International Space Station after it's built. And then at the end of any shuttle mission to the space station, whatever surplus propellant is left over can be used to reboost the space station in a towing mode. This tether is about 3 kilometers long. It'll take about 1.5 hours to 2 hours to wind. For the 20-kilometer tethers, the actual winding time is about 8 hours. That's distributed over a longer period with, lunch breaks and things like that. I've been a space enthusiast for 30 years and never expected my concepts that I played with as ideas to be taken seriously. But 15 years ago, NASA got interested in a concept of mine involving a way to use tethers. This led to my opportunity to build flight hardware, and it's been a great satisfaction and very thrilling to have the opportunity to fly your own hardware and actually see it in space.
Launched by a rocket in 1994, this satellite tether was the first man-made object in space to be visible from Earth as anything but a point of light. It had a shape.
This experiment was satisfying and exhilarating in many respects, but one of the most surprising was the fact that the tether itself was actually visible to the naked eye. It was a great surprise to many people that something about the size of a kite string would be visible from hundreds of miles away.
You calibrate your scopes with it, get some resolution.
Some people described it as a glowing Jedi sword gliding across the desert sky.
Joe's remarkable 12-mile-long tether was visible to the naked eye because it was shiny enough to reflect sunlight.
Oh, that's great. What? It's great through the binoculars.
Soon tethers may move cargo, maybe even manned spacecraft, from Earth orbit to the surface of the Moon. It's all a matter of energy transfer. When there's no atmosphere to interfere with an object's momentum, momentum can be passed from object to object. The cargo is grabbed by the tether system, then maneuvered through space to higher orbits. To get to the Moon, it's a 4-day trip. In lunar orbit, the parcel is caught by another tether and dropped gently down to the surface of the Moon. And of course, it would work just as well in the opposite direction, which means that there could be constant traffic between Earth and Moon without the cost of fuel. But the Moon is just a local stop, and space, to say the least, is vast. What about going to the nearest star, Alpha Centauri, 100 billion moon distances away? Even the difference between the Moon and Mars is like the difference between the house next door and one in another city. So to travel in deep space, other technologies will be needed. Here at the Air Force Research Laboratory in the sunny Mojave Desert, they're working on solar propulsion. The pressure of sunlight on solar panels could push ships through space, or the light could be converted into power for electric motors. Or an inflatable solar concentrator like this could heat the propellant in rocket engines. This would allow for rocketry, but with much lighter fuel and much more efficiency. Nearby, a new type of fuel is tested in chambers that simulate space. This is a pulsed plasma thruster. It heats Teflon to a temperature so high that it turns into a completely different state of matter, a plasma. This can maneuver spacecraft or satellites. But how do you invent a new rocket ship? To do that, there's a remarkable computing system that seems to turn dreams into reality. It's called rapid prototyping. A designer draws into a computer, and then another computer takes the drawings, analyzes them, and compiles them, layer by layer, into the designer's wish.